Hello everyone. We are very glad to give this video abstract. In this paper, we study certain exponential sums with Piatetski-Shapiro sequences and their application to modular hyperbolas. The Piatetski-Shapiro sequence associated with C is given by the first formula. We call it Pi sequence. Here, C is a real number greater than 1, and C is not an integer. Our starting point is Klosterman sums with Pi sequences, defined as in the blue formula. Spalitsky and Technol studied the sums defined above, and they obtained a non-trivial bond when C is less than 4/3 and N is in this range. Our motivations mainly come from their results. On the one hand, Spalitsky and Technol pointed out that it would be interesting to see how large a value of delta can be chosen. So, our first motivation is to improve proposition 1.1. On the other hand, we note that Rx plus S times inverse of x is a rational function over Fp. Therefore, it is natural to consider its bond with Pi sequences. Assume that Gx and Hx are coprime polynomials. We focus on the sums defined as in the first formula. Assume that the rational function g over h is not a constant or linear polynomial. Suppose also that c is less than 3 seconds and n is greater than the blue value. We obtain a new bond in theorem 1.1. Now, we give some remarks on theorem 1.1. Firstly, the proof method of theorem 1.1 mainly comes from Baker and Banks. Secondly, theorem 1.1 improves proposition 1.1 when C is less than 6/5. Here, we give an example. Finally, we also remark that theorem 1.1 removes the upper bound of n, but the lower bound of n is worse than proposition 1.1. In theorem 1.2, we give a non-trivial bond for SGHCPn by applying the method of proposition 1.1. The original method can be found in the paper of Banks and Spalitsky. In some intermediate process, we have done some new work based on Merrill's method. We note that theorem 1.2 requires C to be less than 4/3, N to be in the blue range, and the degree of the polynomials Gx and Hx are less than log p. At the end of this paper, we study a problem concerning modular hyperbolas and Pi sequences. The classical modular hyperbola is defined as in the first formula. His-Brown proved that there exists a point on this modular hyperbola such that both coordinates are less than 2 times log p times p to the 3/4 power. Here, we consider a new modular hyperbola, which is defined as in the second formula. In the last theorem, we further study an analog problem of His-Brown when the first variable belongs to the general modular hyperbola and some fixed Pi sequence. That is all of our video abstract. Thanks for your attention.